Hi, in this video I'm going to give you some help and advice for completing homework 3 about multiple regression. So make sure you are here in the Moodle site and you can download the Markdown file to a Downloads folder and have access to the homework 3 processed version. And I've already gone to the RStudio server and opened up my document. I used the upload feature to bring up the R Markdown homework 3 multiple linear regression file, and I've got that opened in my Markdown window for homework 3. And the only set of data that we're going to use is from the Berkeley Guidance Study. These are boys and girls that were followed over their childhood up till age 18. In this particular homework, we're going to study the BGS girls data set. This is a built-in data set in the ALR4 library package. So make sure you have that running and loaded, and we will be using the BGS girls data. And the variables that we're going to be looking at in this first part of the problem, in problem 1A, are weight and height for girls at age 2 and at age 9. Weight 2, WT2, means the weight in kilograms at age 2. WT9 means the weight in kilograms at age 9. Height 2 and height 9 are heights measured in centimeters. There is a body mass index variable that is a combined function of height and weight at age 18. It's a measure of health and body size, and that variable is BMI 18. There is a variable SOMA, which stands for somatotype, and that is a measure of body shape. Higher values mean a more rounder apple pear shaped body, and smaller values mean more vertical and elongated body shape. The first part of the problem, problem 1A, is asking you to get summary statistics and a scatterplot matrix and a correlation matrix, and comment on the strength and direction of relationships between these variables. Height and weight at age 2, weight and height at age 9. I believe LG9 is leg circumference at age 9, and then body mass index and SOMA. In lines 34 and 35, I get summary statistics for the variables in BGS girls. In line 35, we are producing a correlation matrix, which is a tabular display of all of the correlations of every variable with every other variable. Now, I am only using a few of the variables in the BGS girls data set, and I'm selecting the ones I want here with this notation. I'm going to be using variables 1 to 5, variable 11, and variable 12. And I know the locations of them because I counted the locations in the BGS girls summary data. In line 40, we're going to do a scatterplot matrix of those variables and observe the patterns. If you take a look at what that Markdown file produces, here is a table of summary statistics for all the variables in BGS girls. For example, weight at age 2, the minimum value is 10.2 kilograms. The heaviest girl in the data set has 17 kilograms, and so forth for the other values in the data set, or the other variables in the data set. Then we proceed to the correlation matrix, and the way you would read this is the first row is weight at age 2, and then as you move across the columns, it's the correlation of every other variable correlated with weight at age 2. You'll notice weight at age 2 is perfectly correlated with itself, and you'll see that weight at age 2 has a correlation of 0.645 with height at age 2, and other correlations with the other variables in the data set. And if you're interested in a particular correlation, like body mass index with leg circumference. You go to the corner of body mass index and the column of leg circumference, and the correlation is 0.568. So a moderately positive correlation. Remember, correlations can run between +1 as a maximum and -1 as a minimum. Variables that are uncorrelated would be close to 0. The scatterplot matrix shows every variable plotted against every other variable. So, for example, in this top row of the scatterplot matrix, we have somatotype in every one of these plots. Somatotype is the vertical axis. So the plot that is in the first row, second column, has vertical axis of somatotype and horizontal axis of weight at age 2, somatotype and height at age 2, and so forth for all of the other places in this matrix. When you look down the diagonal, you can see a sort of smoothed histogram of the distribution for each of the variables. For example, down here on body mass index, it looks like there's some evidence of a skewed right pattern. There's a few girls that are very overweight, but not many of them, but they extend out to some very high body mass index values. Anything over 25 is overweight, anything over 30 is obese. So this particular distribution looks a little bit skewed right. And so what I would like you to do here is make sure you understand the summary statistics, the correlation values, and the scatterplot matrix of how to read it, and notice some things like which variables are very uncorrelated with each other that really don't show any particular upward or downward pattern, which variables seem to be very correlated with each other. Like, for example, this one seems to be a very strong positive correlation, and there are others like that. So I want you to go through here and make comments about which variables appear to be very strongly correlated, which ones are less correlated, and the other interesting features, and put your comments right here on line 45 where it says comments. Our next problem, 1b, is the idea of an added variable plot. As you have gone through the notes and the textbook and my YouTube video about added variable plots, you will get a chance to do one yourself here. We're going to have a response variable that is somatotype, and we are going to have a model where somatotype is explained by the weight at age 9, and we are going to then consider adding the additional predictor variable leg circumference at age 9 to the model and get an added variable plot that shows the effect of adding an additional variable. And so in line 56 we have the basic model that has the 2 predictors in it. We look at some coefficient summaries for that in line 57, and then in line 64 we get a printout of the added variable plot for adding leg circumference at age 9 into a model that already has weight at age 9 in the model, and we get an added variable plot that looks like that one. And then from the notes and the lecture and the overheads, I want you to write a description about what this added variable plot tells you about the problem at hand. Problem 1c, again, somatotype is our response variable. This time we're going to have height and weight at age 2, height and weight at age 9, and strength at age 9 as our predictors. And we'll make a model with those in line 74 and summarize it and give summary statistics in line 75. In the markdown file, there is a whole section of code here. Line 82 down to line 111 is a bunch of commands which you don't need to worry about. I use it for my answer key, but you don't need to worry about all these commands. What you need to primarily be focused on here is the output from lines 74 and 75. If you look at the processed version, you will see that output right here. Here is the summary table that displays all the beta hat estimates and standard errors for this particular multiple regression model. What I want you to do with it is to understand what's going on here, understand the model summary things like R squared and the residual standard error, and I want you to do a series of hypothesis tests. And those are outlined here in lines 119 down to 131. I want you to examine the effect of adding height at age 2 to the multiple regression model after adjusting for other variables. I want you to examine height at age 9 added to the model and weight at age 9. Remember from our notes in our course that talking about an effect of a particular predictor means you're examining a hypothesis test about a particular beta parameter. In this case, beta 1 represents the effect and the impact of height at age 2 on somatotype at age 18, and the other betas represent and capture the effects of those predictors. So I would like you to use the notes and perform these hypothesis tests. Go to the processed output, grab the appropriate value of the t-statistic for the correct coefficient, type that in here for t-statistic, use the output to get the appropriate p-value for your test. Remember, the p-values are going to be in this column. Just make sure you use the appropriate one for the appropriate test, and then make a correctly worded conclusion following the examples from the last homework and from the notes about this one, making sure you give conclusions phrased and worded as I desire. In problem 1D, we have a slightly different model now. We have height and weight at age 2, strength at age 9, but this time we are going to use body mass index as the response variable. And what I want you to do for this one is to use the confidence intervals for each coefficient, not tests, but confidence intervals, and give conclusions about the effect of height at age 2, height at age 9, weight at age 9 on body mass index values, but using the confidence interval in your conclusion and in your discussion. If you look at the process file, you'll see I have done that right here. Problem 1D, we have the model, we have the summary, and then we have the confint or confidence interval command for reasonable ranges for these beta coefficients. Make sure you look through the notes and the textbook and the examples for how to phrase conclusions about these effects using confidence intervals. In problem 1E, we're going to consider a particular 2-year-old girl that has a height of 80.25 centimeters, an age 2 weight of 17.5 kilograms, and we're going to be using a multiple regression model to predict this girl's body mass index at age 18 just from her age 2 information. But for the time being in this problem, I want you to go back to the beginning of the homework and use the summary statistics and the scatterplot matrix values to describe the physical appearance of this girl. Is she tall? Is she short? Is she thin? Is she heavy? Use the predictor height and weight information that I've given you and the processed output back up here at the beginning that shows the scatterplot matrix with the variables related to each other. Look at the correlations, look at the summary statistics, and give me some sort of description about the physical appearance, the physical nature of this girl, and give me an appropriately argued answer right here in line 162. In problem 1F, we consider the same girl again, only we're going to use a multiple regression model to make a prediction and model her body mass index and model model body mass index based on age 2, height, and weight. And we make that model right here in line 170. We do a summary of it in line 171. And then we make a prediction for this girl's weight and height. And what I want you to do in this question is I want you to look at the results of the model. I want you to think about what's going on, and I want you to make a decision about whether you think it's reasonable to predict and believe that this girl is going to be overweight, body mass index more than 25 at the age of 18. So realize this is a question about an individual value of the response variable y, body mass index. And what's crucial is, do you think, given the age 2 information, do you think you can be sure or be reasonably sure and clear that this girl will be overweight and that her body mass index when she gets to be age 18 will be over 25? Do you think that's true? Use the output here in 1F to make that decision. In problem 1G, I want you to think about what has been going on in this model in the previous problem, and do you think this model is good and going to give accurate explanations of a girl's body mass index? Look at the summary things about this model and use what you've learned in this section to make a judgment or a decision about whether you think this model is going to give a good, accurate projection about what a girl's body mass index is going to be. Hopefully that will give you some idea about what you need to do when you finish and work up your markdown file. Make sure you submit that right here under multiple regression, and when you're ready and you feel like you know what's going on, take the assessment quiz. Most of the points for this assignment are on the assessment quiz. You'll get some points on the written part. Make sure you have the written work available when you start doing the online assessment. There is a time limit, so make sure you've done all the written work before you do the assessment, because there are questions on the assessment that you will need the processed file for your answers. So make sure you do that. When you have finished and done all the work and I've graded it, the solution key will appear. Let me know if you have questions about this.